guys, week 2. So you got 1 week of virtual learning under your belt, and I must say you guys did a great job. There were a few people that asked, like, where do I post my work? So I don't really care if you post it on Google Classroom or just send me a picture of your work. And it doesn't have to be on the exact sheet that I post. If you just want to write down the problems and write your answers all worked out on a piece of notebook paper or just a piece of paper, whatever you got, I will take. I'm not going to be picky about that. So this week I'm going to work on giving you feedback from last week. But yeah, this whole quarantine thing's kind of crazy. As you can tell, Lady is very, very concerned about it. She has taken several naps today to console herself with it. But I just want to say that I never in my life thought that I would miss school as much as I do right now. So I miss all of your faces, and I hope that you're having a safe but good time at home. And just stay healthy, and hopefully I get to see you guys before May, because who knows at this point. But yeah, email with questions. I can do video chats or whatever. If you are not understanding something, just really reach out, advocate for yourself. But yeah, I really miss you guys, and I hope you have a really good week this week. Bye. Lady, can you say bye? She says bye, I promise. She's pathetic, but I love her. All right, last week you guys did a great job converting logs to exponential functions and then back into log functions. So this week we are just focusing on logs, and we are doing what's called expanding and condensing. So the first assignment is the expanding, but here are the rules that you need to know before we even really begin showing any kind of examples. So think back to the exponent rules. Whenever we had multiplication, we added those exponents. It's going to be very similar with the logs. So multiplication and addition go together, and then division and subtraction go together. Now, the other rule that you need to know is that exponents move to the front of the log. So just keep that in mind. I'll explain what each of those mean, but I also want to reintroduce this rule here. Remember that n was the root number and it's always on the bottom like a tree. The exponent is raised up, so it's always on the top. So just keep that in mind whenever you see roots. We can rewrite those as exponents, and I'm going to do an example of that. So these examples are like the ones that are on your worksheets. So this first one, I have division, which I'm expanding, which means I need to have my answer should have more than one log. So in this case, there are 2 different parts. So that means my answer is going to have 2 different logs. And since it's division, that means that these should be subtracted by each other. So my answer is literally just log base 9, and then the top, which is u. And then again, since division means subtraction, I'm going to subtract another log base 9, because they need to be the same, since this was log base 9 here, and then of that bottom part, which was v. And that's my answer. That we just expanded that log. So again, division meant we were subtracting. And since there were 2 parts, that means I'm going to have 2 logs. So moving on to number 4, I have 2 things being multiplied. Since I'm expanding, that means I'm going to have 2 different logs in my answer. So if I go back to these rules very quickly, multiplication actually means addition. So when I'm working this, if I'm expanding it, I have log base 7 of the first part, which is x. And then again, since I have multiplication, that means I'm adding So another log base 7 of the second part, which is y, and there's my answer. Okay, so there's the multiplication addition. So now let's talk about one that has that root. So this one I'm going to do in 2 different colors. So this guy has an exponent, since there's none written, of 1. So this could be written as log base 5 of 7. And then if we remember this rule, the exponent goes on top, the root number goes on bottom. So in my case here, my exponent is 1, so it goes on top. And then the root number is 3, that goes on bottom. So here is the other version of this problem. And if I look back at this rule, exponents move to the front of the log. This is literally the easiest rule, because literally all this exponent does is it moves to the front of that log. So literally my answer is 1/3 log base 5 of 7. Now, another way that you may see it written, so I'm going to write this as well, is a 3 on the bottom for that 1/3, and then log base 5 of 7 on top. So either one of these answers I will take, but you will probably see it most often looking like this, which again just means that it's a 1/3 at the front. So if this was a 2, this would be the same as having 1/2 in front. So that's all it is. All right. And the last expanding one I'm going to do is like number 12 on your assignment. This one has more than one thing happening. So I see an exponent and another exponent, and I see division. So I'm going to start with that division. I have 2 things that are being divided. So I know that I have log base 6 of that top part, which is x. And I know that it's going to be subtracted by log base 6 of the bottom, which is y squared, right? But I know that this whole thing was encased by this 3. So where do exponents go? To the front of the log. So each of these should have a 3. But am I done there? Absolutely not. I hope you said no, because of this exponent here. So this guy is done. 3 log base 6 of x, he's done. Awesome. But this 2 also needs to move to the front. And so we're going to multiply those 2 things. So 3 times 2 would give us 6 log base 6 of y. So again, exponents always move to the front. So once you get done, make sure that you are checking that you have no exponents, you have no multiplication, no division. So that is expanding logs. All right, so now your second assignment is condensing logs. So it's actually just doing the opposite. So we're working backwards. This time we have 2 logs. We want to make it condensed into 1 log. So each of these answers should only have 1 log as the answer. So when I have addition, hopefully you remember from our rules, which I'll zoom out just a little bit, addition means the same as multiplication. So what I have here is 11 times 2. And you can just leave it like that. You don't have to change it to 22. Like, this is perfectly great. Okay, so again, with condensing, I just want to make sure that I emphasize that your answers should only have 1 log. When you are expanding, that's when you have multiple logs in your answer. But condensing, you only have 1. So this is like number 6, which is very similar to the example we did with expanding. So when we had a 3 on the bottom, it was the same as having 1/3 in front of the log. Which, when you have a number in front, all that means is it was an exponent. So an exponent just moves backwards in this case, because again, you're doing the opposite. So we have log base 5 of a to the 1/3. But I know that 1/3 is the same as a root. So this actually goes one step further and becomes log base 5 with a root. I know that a goes in here with an exponent of 1, and then the root number is the bottom number, which is 3. So here is my final answer here. So numbers in front just get moved back to being the exponent, but in this case, since it was a fraction, that actually means it's a root. Okay, so let's do one more example. This is number 9. So I just wanted to do one more example with exponents just to make sure that we understand that they get moved back. So again, I know that since I'm condensing, I'm only going to have one log with my answer. And since I see subtraction, hopefully you remembered that that was the same as what? Hopefully you said division. So I know that I have an x and I'm subtracting it with y. So I'm going to go ahead and put x and y. But in front of this log with x, there was a 6. 6 is that exponent that gets moved back. So 6 goes with the x. Now here, there's a 36 in front of it. 36 gets moved back, and there is a 36 as an exponent with y. So again, this negative in here only referred to the division. It's not making anything, any number negative. So that is expanding and condensing. So I will post an extra video just to make sure that we have some extra examples if you need it. But that is the gist of it. Email me if you have any further questions.